Hello everyone, in today's video we are going to discuss hydroelectric power plants. Objectives: at the end of this video you will be able to number 1. Visit the various stages of a hydroelectric plant. Number 2. Interpret the functions of each hydroelectric plant. Number 3. Prepare and draw the schematic diagram of the hydroelectric plant. Let us discuss hydroelectric power plants. Hydroelectric power stations are generally located in hilly areas where dams can be conveniently built and large water reservoirs can be obtained. From the dam, water is led to a water turbine. The water turbine captures the energy in the falling water and changes the hydraulic energy, that is, the product of the head and flow of water, into mechanical energy at the turbine shaft. The turbine drives the alternator, which converts mechanical energy into electrical energy. Hydroelectric power stations are becoming very popular because the reserves of fuels, that is, coal and oil, are depleting day by day. The potential energy in the water held in the dam is transformed into kinetic energy of water in hydroelectric power plants. The turbine at the base of the dam is supplied with swiftly moving water from the dam. The turbine is propelled by the kinetic energy of the moving water. The generator is then propelled by a turbine to produce power. In terms of hydroelectric power capacity installed, India is 5th in the world. India had installed utility-scale hydroelectric capacity of 46,000 megawatts as the end of March 2020, or 12.3% of its total utility power production capacity. Step 1. Visit the stages of a hydroelectric power plant. That is, number 1. Hydraulic structures. Number 2. Water turbines. Number 3. Electrical equipments. Step 2. Identify the following stages of a hydroelectric plant and write down their functions. Hydraulic structures in a hydroelectric power station include dam, spillways, headworks, surge tank, penstock, and accessory works. Constituents: dam. Type: diversion dam. Function: a dam is a higher barrier which stores water and creates waterhead. Dams are built of concrete or stone masonry, earth, or rock fill. The type and arrangement depends upon the topography of the site. Constituents: spillways. Type: subsidiary spillways. Function: there are times when the river flow exceeds the storage capacity of the reservoir. Such a situation arises during heavy rainfall in the catchment area. In order to discharge the surplus water from the storage reservoir into the water on the downstream side of the dam, spillways are used. Constituents: headworks. Type: storage headworks. Function: the headworks consist of the diversion structures at the head of an intake. They generally include booms and racks for diverting floating debris, sluices for bypassing the debris and sediments, and valves for controlling the flow of water to the turbine. Constituents: surge tank. Type: restricted orifice surge tank. Function: a surge tank is located near the beginning of the conduit. When the turbine is running at a steady load, there are no surges in the flow of water through the conduit is just sufficient to meet the turbine requirements. However, when the load on the turbine decreases, the governor closes the gates of the turbine, reducing water supply to the turbine. The excess water at the lower end of the conduit rushes back to the surge tank and increases its water level. Thus, the conduit is prevented from bursting. Constituents: penstocks. Type: high-density polythene. Function: penstocks are open or closed conduits which carry water to the turbines. They are generally made of reinforced concrete or steel. The thickness of the penstock increases with the head or working pressure. Various devices such as automatic butterfly valve, air valve, and surge tank are provided for the protection of penstock. Constituents: tail race. Type: mill race. Function: the tail race is the channel which carries water known as tailwater away from the powerhouse after it has passed through the turbine. It may be the natural stream channel or a specially excavated channel entering the natural stream at some point downstream from the powerhouse. Constituents: draft tube. Type: conical draft tube. Function: the draft tube converts the kinetic energy of the water into static pressure at the turbine's output. It is typically located near the exit or exhaust of the turbine. This keeps the water's kinetic energy from dissipating as it passes through the turbine's output. Constituents: turbine. Type: impulse turbine. Function: water turbines are used to convert the energy of falling water into mechanical energy. The principal types of water turbines are impulse turbines, reaction turbines. Number 1. Impulse turbine. Such turbines are used for high heads. In an impulse turbine, the entire pressure of water is converted into kinetic energy in a nozzle, and the velocity of the jet drives the wheel, that is, Pelton wheel. It consists of a wheel fitted with elliptical buckets along its periphery. Number 2. Reaction turbines. Reaction turbines are used for low and medium heads. In a reaction turbine, water enters the runner partly with pressure, partly with velocity head. The important types of reaction turbines are: number A. Francis turbines. B. Kaplan turbines. Step 3. Note down the speed of the water turbine and other details and enter it in the diary. Step 4. Trace the various parts of alternator and note down the nameplate details in table. Number of phase 3. Capacity 5 megawatts. Speed 1000 revolutions per minute. Output voltage 440 volts. Current 800 amperes. Frequency 50 hertz. Excitation current 100 amperes. Serial number: year of manufacturing 1986. Model number. Step 5. Draw the schematic arrangement of a hydroelectric power station. Step 6. Note down the mean step-up transformer specifications and the type of cooling arrangements. Step 7. Ensure that the cooling arrangement of a power transformer is cooling down or any other types. Step 8. Note the transmitting voltage range and the number of transmission lines. Step 9. Note down the total installed capacity of the power station and maximum number of turbines working together at peak load hours. So far, we have discussed the various stages of a hydroelectric plant and interpreted the functions of each hydroelectric plant. Thank you and have a good day.